All right, thank you very much for joining us today. Today we are going to demonstrate a powerful tool within Altium Designer that is called the IPC Compliant Footprint Batch Generator. It was added to Altium Designer several years ago when they first put in the IPC Compliant Footprint Wizard. Now it allows users to generate a number of footprints simply by providing a spreadsheet of package component dimensions. All right, we'll demonstrate that. This powerful tool is, as far as I'm concerned, very underutilized, and unfortunately the literature on it is rather limited. However, hopefully after we're done presenting this, that this video will bring its power and capability to light. So, and just one other note before we begin, the files that we will be using in this demonstration are available to you, and they can be found in the link that is provided in the description of this video on YouTube. All right. So let's begin. What I've done at this point is I am in a PCB library and is currently empty. And what I want to bring up first and foremost is the actual wizard itself. So I'm going to go into tools, pardon me, not the wizard, the batch generator. So there is both the wizard and the batch generator, and I'm going to mention that there is another video that we have done on the wizard. It's also on YouTube as well. So if you want to know more about the specifics of the wizard, then certainly go over there. And we are going to look at the wizard a little bit more, but we're not going to go into a great amount of detail in it. The only reason why we may bring up the wizard here a little bit later on is because we want to show what the wizard can do versus what the batch generator is going to do. Alright, so I'm going to bring up the batch generator at this point. And now the dialog box comes up. Alright, and what Altium has done for us is they've already actually provided the templates that are necessary for us to actually put the information in. So we don't have to go into a spreadsheet or go onto the wiki or try to find some other example. Altium's already provided that for us. And the way we get to that is we go over here to this button that says Open Template. And if we do the drop down, you can see all the different package types that Altium Designer recognizes and has an equivalent wizard feature for. So what we're going to do today is we're actually going to do the 2-pad chip surface mount devices. And this is one of the more simpler ones to do, but if you understand how this works, all the other ones are simply going to fall into play. So we're going to click on this, and it actually brings up your Excel, or if you have your, if you're using the other versions or the freeware tools, they'll bring that up as well. But what it's going to bring up is an Excel sheet that exists in your templates, and this is what it has over here. These are the things that we're going to have to fill out. So the footprint name, description, these various things over here, and then there's also footprint specifications, which we can use to override some of the things that are going on in the package specifications. Now, in addition to this, rather than having to go onto the wiki and get some more information, Altium's actually provided all the information for you over here in both the legend for the package, you can see that over here, and for the footprint information as well. So we know what all these columns mean and what they're looking for in those columns. There are some little quirky things there, and we'll show you those as we're going along, but generally speaking, if we fill in the blanks, we'll be able to build this by just providing the data. All right. So these are all the things that we do need to fill in, at least on this side over here, and not everything is necessarily even needed on this side, and then again, the footprint specifications can override some of the things that are going on over here. Now what I'm going to do is not something that most people would normally do when they're trading this. Normally you take out a spreadsheet from a data company that has all the data for your footprint packages, and you type that stuff in over here. But what I'm going to do for this demonstration is I'm going to take this over here and I'm going to compare it against the actual footprint wizard, so you can see what the footprint wizard has and what the batch has. I'm going to move this over to the other screen. Okay, so what we did over here was we basically moved Altium Designer out, and we went into the file menu under Tools and opened up the IPC Compliant Footprint Wizard. And we moved Altium Designer out because if we were trying to use the wizard and trying to show you the Excel sheet at the exact same time, Altium was going to hide the sheet. So we took a moment out to remove Altium Designer. Now we have just the wizard up over here, and we have the Excel sheet. And what we're going to do is we are going to show you what's going on in the wizard, and at the same time we're going to show you what information we're going to put in here in the package and the footprint specification. So let's press next here. Okay, so we are going to be doing a chip, and that's already been selected, and we'll press next. Now one of the things that the wizard's very good about doing is retaining information. So fortunately when we went through this before, we already put the information in, and now you can see that this information is still there. And this is very nice because if you're working on individual components, you don't have to keep re-entering that stuff every time. The information's already in there. Now, of course, if you're using the batch, it's because you're trying to do dozens of components, and that's what makes the batch very effective and useful. Nevertheless, let's begin where we are at here. So if we go over to the batch here, the first thing that they provide is the footprint name and the footprint description. And oddly enough, this is the very last page of the wizard. And so we will get to this. It's just that it's not going to show up here on the first page. What we're going to start with is the L's, W's, T's, and over here the A's here, which are the maximum height. So let's begin with this. So L min is basically the body length range, and you can see what all these letters represent over here in the picture that they've provided for you. And I'm going to just simply type this information in. So the minimum here, which is L min, is 0.9, so we'll put that in here. Okay, and the L max here is 1.1. All right, the W here, the min, is 0.4. And the max here is 0.6. The T, same thing here, just 0.1 for the minimum. And we have 0.3 for the maximum. Now here it gets a little bit interesting. The batch is actually asking for both a height of a minimum height and a maximum height. Well, Altium Designer doesn't really provide you a minimum. It just wants a height. So in this case over here, we could either leave this blank, but just to keep it all kind of complete, we're just going to say, look, the minimum height and the maximum height are the same thing, so we'll put 0.6 in. There's one other thing I'm going to note here before we continue. You'll notice that all of these are in millimeters. The wizard has to work in millimeters. Now, the wizard can work in both millimeters and in mils. The batch can only work in millimeters. So just keep in mind that when you're doing these, all these have to be in millimeters. Now we get over to the package type over here. And this is one thing that the batch seems to have a little more of an advantage over the wizard. So in the wizard over here, if we look, you can see that there's a chip capacitor and there's two other flavors. There's for inductors and resistors. However, the package type over here also includes diodes for the batch. And we can see that if we go over here to the legend package, you'll see the package type also allows for a diode here as well. So we can put in a C, an I, R, or a D, and that will tell Altium which type of component we want to use. So you'll notice that the diode is not available over here. So there's one advantage that you do have if you're using the batch. Okay. Now, depending on which one you pick over here, they also provide for orientation. Now, if I was to pick a resistor, for example, you'll notice that the pin location disappeared because there's no orientation for it. But if I picked, for example, a capacitor or even the inductor, it's going to require, well, it doesn't say it doesn't require, it's optional that you provide either pin 1 or pin 2. Right? So just to kind of keep this interesting, we will say pin 1 here. So we'll do a chip capacitor with pin 1. If I go over here, the package type is going to be the letter C, and that the polarity pin actually matches up to the positive pin location. So I'm going to put in pin 1. Okay. So I'm going to click this over here so we can continue along, and I'm going to move over to the next page. Now, this over here is not included in the batch, at least not from a straightforward point of view. You'll see that this says S. But this actually is G over here, and we'll talk more about C, G, and Z over here in a couple of minutes. But for now, we're just going to skip this over. Now we're going to get over here to the various fillets. All right, and we are going to use the values here, and we have 3 columns for this information, along with the density level as well. So actually, let's start with the density level. So there's 3 different density levels that you can use, and Altium Designer wants a density level, but we don't put A, B, or C in here. Actually, what we need to put in, again, if we go back to our legend, we can see over here that we should do M for most, or N for nominal, and if we push this over a little bit, you'll see that there's L for least. So for this one, we'll just simply keep it at level B, medium density. So we will use over here the nominal here. So we'll leave this at level B, and so when we put this in, we're going to put the letter N in the data. So let's go over here to level density, and we'll put the letter N. And then we're just going to follow this information here. So this says 0.43, so we'll put that in here. And for this one over here, we'll put minus 0.006. And then for this one over here, we'll put in minus 0.02. All right. Oh, one other thing before I continue on with the drawing notes here. I'm going to go back to the legend and just let you know that these fillets over here are indeed optional, so you don't necessarily have to put these in. So just giving you a little more feature and control over things here. So let's move back over to data. So now we get to the drawing note, and unfortunately this may be a bug in the system. You can put whatever you want to type over here. Unfortunately, if you do put any characters or strings in there, Altium's going to come back with something on the silk that says C drawing note. And so we've experimented with this a couple of times. We've not been able to decipher what that means. If you leave it blank, it won't put anything on the screen, and so therefore, just to keep things simple here, we're not going to add anything to the drawing note. Alright, so now at this point we have enough information to actually run the batch generation, believe it or not. But before we do that, let's continue with what the wizard has and see if we want to add a few things here to the footprint specification. So I'm going to click on Next. So this is the chip component tolerances. I love how they have that twice. But nevertheless, this information does not show up here in the batches, the batch file, so we're going to continue on here. The same thing with these tolerances, so we're going to continue on here as well. Now we start getting into more specific footprint specifications, and X, Y, and C both show up over here. So let's take care of the easy one first. We're going to put in the X first, which is 0.6. Okay. And then we are going to do, oh, pardon me, that's in the G, so let's go over here to X, and we'll put in our 0.6. Then we go into Y, and that will be 0.8. And then for C, we're going to put in 1.2. But before we continue, let's talk about C, because C, Z, and G do have an impact on each other. Now C will override G, Z, and G. And what does that mean? What are these different things representing? So let me click over here on the footprint legend, all right? And you will see that the Z, and I'll bring it in here a little bit more in focus, what the Z represents is the distance between pads measured on the outside edges. So if you see where my cursor is here on the wizard, it's from this edge out to this edge. The second one that you have is the G, and this would measure it in theory from the inside edge to the inside edge. And then C becomes basically the distance between the pad centers. Now, the way Altium has set this up is that if you provide information for C, you still have to provide information for Z and G. It will actually bark at you if you don't, but it will only look at C and ignore Z and G. So it's a kind of a little of a quirky thing, but it gives precedence to C, but it still wants to see values for Z and G. So you can, in theory, put anything you want here, but in the end, C will be the one that will receive it. Now, that's assuming that you put anything in any of this to begin with. If you put nothing there, then you don't have to worry about it. But the minute you start playing with these here, it really does want values for all three. But C will take precedence. If C is not there, G will take precedence. And if G is not there, Z will take precedence. So just wanted to bring that to your attention over here as to how Altium is handling that. But we do have a C value. And just for Z, and just to show you that it's going to ignore it, I'm going to put an outrageous number in here. I'm going to put this at 100, and I'll put this one at 80. And Altium will ignore those numbers, because it will do this if we want to take a measurement afterwards. So let's go now to the next one here. So we got this information, all right, and now we get the information for R1 and for R2. Okay, and this has been set to 0, 0. Okay, and we can do the same thing here, and we'll just put this at 0, 0. And you know, keep in mind that what we're just trying to do is compare this between what's going to happen in the wizard and the batch. So even if these end up in odd locations, at least you'll see that they're both going to end up in the same odd location when we create both of these here. So that's what we've got here. We're going to press Next. All right, and then now we've got our V1, V2, and our A and our B. So these are the courtyard information. Now keep in mind that the courtyard is not really an IPC thing per se. It's really more for the assembly and for the manufacturing data. So when I say the IPC thing, I'm talking about the actual copper footprints. These are really things that end up on the mechanical layers, and they're just there for the references for those guys doing either the manufacturing or the assembly of the boards. So let's go over here to V1, and we're going to put the information in. That's 2.3, and then V2 is 0.9. We'll go over here to A, which is 1.1, and then we'll go here to B, which is 0.6. Okay? So at this point in time, we actually have everything completed in this. Now before I continue on, I want to save this, but if I do a file save, I'll actually save this to the original template. So what I am going to do is I'm going to click over here onto File, and I'm going to do a File Save As, and I'm going to go up over here to my desktop, okay, and I'm going to save this over here like so, and we'll say Chip Components, and we'll call it Demonstration. Okay, and we'll press Save. So at this point in time, we're actually done with our Excel, and now we're going to move back over to Altium Designer to see what happens when we run both of these. And before we do anything else, what I'm going to do here is I'm going to click Next, Actually, before we go to anywhere else, let me go through this over here. You'll notice that there is a name and there is a description. So this is what Altium's going to add to the wizard. What about us? Well, we have some options over here. We don't have to put a footprint name and we don't have to put a footprint description. Now, a footprint name is beneficial because if there is a style that you want, that's the style that you can use. Now, if you want to let Altium name it, in this case maybe we'll let it name it, that'll be fine as well. The footprint description is the same thing, and Altium does a really nice job with the description. So I think we're just going to let Altium fill in the blanks on both of these over here. Okay, so I think we're good to go with this. If I press finish, the part has now been made on my other screen here. I'll drag it in, and then what we'll do over here is we'll do a quick swap out. We'll bring this up here. We'll view this in. So this part was the one that was created in the wizard. Now let's create the part from the batch. So I'm going to go into Tools, IPC Compliant Footprints Batch Generator. Okay. Now we're not doing templates anymore. We're actually going to add the file. By the way, one side note that I'm going to do, if you click on this help on and you try to find some more information, it's not going to go very far. And why is that? Because in the old days when Altium Designer used to provide documentation, they used to provide it in the source directory or the root directory. And the document that they used to use is TR, Technical Reference 0114. Now if you type in TR 0114 into the wiki, you will find that document. Just be forewarned that the information in the Excel sheet is a lot more up to date than what you're going to find in the wiki. So just wanted to give you a heads up on that. But what we're going to do now is we're going to add the files. Okay? And you can add multiple files here, which is really kind of a neat feature. And we're going to do a couple of things here. So I'm going to go to my desktop, and I'm going to bring this up, and I'm going to bring up the chip components demonstration, which is the one that I did. Okay, so I'm going to bring it in, but in addition to that, I'm going to bring up another one just to show some variations of what happens if you leave some stuff in or some things that you take out as well. So I'm going to take this one here, chip components, and I'm going to bring that in as well. So if you got a bunch of different files, you can bring them all in. Now you're probably saying, well, no, it's probably easier for me to do this in one Excel sheet, and that's true for the chip components. However, for something like BGAs where Altera or Xilinx is providing very large data sheets, it may be easier to get those sheets from them, touch each one of those sheets up, and then add them in. Okay. Now there's some options over here, and you'll see the output folder is for output. The output folder is basically a folder for the HTML that comes up that tells you about the errors and the warnings. It's a nice way of saying this is where we're going to put the log. Okay. What we're going to do is, because we have the PCB1 library open and we haven't saved it yet, that's where it's going to put the footprints. It also gives us the ability to generate files per input file. So if we clicked on this, it would create a library for this one, and then it would create a library for the second one here. Or if we're doing something like a subversion database library, we can always click on this one and it will create a file for every single footprint that we've asked it to generate. Okay, so we are going to ask it to generate a report on completion to make sure everything looks good over here. And we are set to go. So we're going to press start. Okay, and now you saw a bunch of things flash on the screen. You can see the two files that we use. Here are the fatal errors. There's none. There's no errors, no warnings. Just note that if you do get errors or you do get warnings, the footprint will not get created. So just keep an eye out on that. So we're going to close this at this point, and now we'll bring up the PCB library panel, and you can see a bunch of things that got kind of created over here. Okay, these are the ones that let's see here. So these are the ones, some of these over here got created. For example, the diode and the inductors here were the ones that got created. Also the resistors. These were created in the second file. What we created was the capacitor here. Okay, and you can see, let's drop that back up there. So you can see the differences between the one that we created. Remember, we created one that was in the middle. That was a level, we created this one here, and we created this one over here. And as we click between them, you can see that there is no difference between the one that we created from the batch and the one that we created through the wizard over here. Okay, so these are the two here. We did a nominal and we did this here, and these were created from the other file that we brought in. So, and just to show you a further comparison to them, let me do the following. Let me take here, I'm in this page here, I'm going to page down, okay, and I'm going to do a Control A, which allows me to select all. I'm going to do a Control C, which allows me to copy all. I'm going to put my cursor in the center here for my reference point, and I'm going to drop back up to here. I'm also going to hit the page down key just to zoom me out a little bit. I'm going to do a Control V. Okay, so here are my two parts. And what I want to do at this point is I'm going to do a Shift S, and that allows me to toggle between the different layers. I know I'm going through those kind of quickly, but just to remind people of the capability of the tool. The Shift S allows me to toggle into single layer mode. And the reason why I'm doing this, I just want to compare what you saw between the wizard and the batch. So I'm going to hit the plus key here at this point, okay? And as I'm going through, you'll see that they're very much the same. The way we set this up in the wizard is the same thing we're getting from the batch, okay? And then should get us all the way back to this over here. And if I hit my Shift S key again, then it brings me back to the multi-layer mode. So there's a couple of other things that we brought in here, so you can see what you get if, for example, you brought in the inductor, and if you bring in a resistor, for example. But what I also want to do is I'm going to bring up its Excel sheet so you can see some of the differences of it. Okay, and I'm going to bring this over here so that you can take a look at it. So here is another example of the things that you can do within the sheet here and the results of it. So one of the things that you can see, bring up Altium Designer again and bring up my Excel again. Here we go. Okay, one of the things you can see over here, for example, is that for the resistor we didn't have to add a polarity pin, but in fact you don't even have to add a polarity pin in for the inductors or even for the capacitor. If you do add it in, then you're going to see the dot, and that's what the number 1 is. You can see the different density levels over here. So even though the data is the same, if we file between these, for example, you'll see the variation that Altium's going to add in there because of these different levels. All right, and then the same thing over here. You can see that, for example, these, though they're the exact same, we added in something for Z, G, X, Y, and C. So this would override anything that you would see that was put over here. Now remember, in our example, we put some outrageous numbers over here, but if you really take a look at the distances, for example, that we did between here and here, they should be, I believe, the one, we'll do a measurement, but they're certainly not going to be 100 or 80. So let's do a Control M. There we go, there's our measurement. All right, for some reason my Control M is not working. However, that doesn't stop me from taking the measurement. What I'm going to do is I'm going to go over here to Reports, Measure Distance. Remember, when we did this, we took what was called the C parameter. So we're going to go from 1 over to 2, and you'll notice that this is 1.2 millimeters, which is what we put in there. So we're not seeing some outrageous distance from 80 or 100 meters. So just want to show you that that concept that we were talking about earlier on is indeed what's going on here when Altium put the distances between the two pads. Okay. So one other thing, I'll bring this back over here on the Excel sheet. You'll notice that over here that there was no footprint name and footprint description. So we just wanted to demonstrate to you that if you didn't put this in here, Altium is still going to create this over here. So in this particular instance, because we created it as an inductor, there should actually be a second inductor in here. Let me move this back over here, and you should see that there's not only that one here, there's this one as well. Okay, so there's the two inductors that you can see over here, and both of them were effectively the same in terms of their dimensions. And you can see that here, it's just that Altium would have given it a slightly different name, but that's where it is. So you have a lot of power to work with, and again, this is the most important area of the tool to make sure that the data has been put in there, and this provides the optional information. But whenever you're in doubt, again, go back to your legend and you can see whether you have to put it in or not, and the same thing with the footprints as well. Okay. One of the last things we want to show you over here, just to really demonstrate the power of it, is actually to show you a real example. So what I'm going to do is I'm going to go into Tools, again into the wizard, and this time when I add the file, what I'm going to add in is the chip resistor Panasonic ERJ. So a colleague of mine was kind enough to spend a little bit of time on this and to basically create the Excel sheet on this. Now I'm going to press open over here, but before I do anything else, I'm actually going to bring it up for you so you can see the work that was done in it. So there's about 30 parts that were added in. Okay, and you can see all these parts here, and for the most part they're pretty much the same. However, you'll see that the nominal, the minimum, nominal, and the max have been added for each one of them here. So even though all three of these contain generally the same information, the density level has been changed, and Altium will, you'll see it as I thumb through it, you'll see that these actually will impact the overall dimensions of each of those components. So I'll push this off to the side here. I'm also going to pull this off to the side here as well, because what's kind of neat to watch is to watch Altium auto-generate these all at the same time. So I'm going to hit the Start button here. And you can see that all of these just got generated. and there was just one warning here. So it's existing footprint was not so added because we probably had a name like this already in one of the other files, which is fine. So I'm going to close this over here, and I'm going to bring this in. Let me do a view fit, and let's just take this series over here of the 120607. Okay, and as I bring as I click on each one of these, you'll see that there's going to be a slight variance in them depending on what the dimensions are here for M, N, and L. There is one other thing that should be mentioned over here as well, and this is one of the things that you may want to consider. These names over here were picked because these are very common names that are used by the IPC standard, especially in the United States. You can use the millimeter version of it, however, a lot of people know in 0805 or they know in 0402, so that's why these were set up accordingly. And again, because these names were in here, that's what Altium took. If these names weren't here, these would actually be put into the millimeters. Okay. Now, one other thing we'll show you here, and you can see as we're thumbing along all these things that were added onto that, and that's pretty cool. And I'm going to go to the 3D for a moment to show you the result of it. I'm going to click on VF, View Fit, to bring it in. I'm going to hold down my Shift key. Let's click here. There's my Shift key, and that you can see the bubble. I'm going to right mouse click it, so I turn it, and you can now see it a little bit better. And as I thumb through each one of these, you can see the different sizes. Now, one of the things that Altium does not do is, depending on whether you use a resistor or a capacitor, it keeps the color the exact same. So if you want a resistor that actually has black on it in the center over here, there are ways of doing some global edits. And that's one of the things you're probably going to have to consider here, that not everything can be done within the tool, within the batch. You can do certain things that are global edits to fix these things. So if you are going to do this, one of the first things I'd recommend is you don't batch into a good library. You really want to batch everything into an experimental library, fix what you need so you can do things globally, and then push these things over very easily by copying and pasting them into the other library. Well, let's give you a little bit of a demonstration. If I want to change this particular component body to black, then I can do that. So what I'm going to do here is I'm going to hit my 2 key to bring me back over here to the 2D version. I'm going to page down a little bit. And then I'm going to hit mechanical 13 because this is where my mechanical is on, or pardon me, my 3D body is on. And I'll click here. I want my 3D. Okay. And I'm going to right click here. And I'm going to start what's called Find Similar Objects. Now this is a little bit of a tangent over here, and this probably really should be addressed in a completely different video. However, I think it's important because it is a part of this whole batching thing. So we're going to just go through this kind of quickly. Anytime you click on a primitive, you can get to Find Similar Objects. All right, and it's just a matter of right-clicking onto it and clicking Find Similar Objects. And then whatever primitive you clicked on, it will provide you all the properties of that particular part, which is over here, and then whatever primitive you selected, which was a 3D body, it's going to show all its properties. And the key thing over here is to basically select those other components that will be the same on the other ones. So if I'm trying to change this on all the other ones here, then what I want to do is I want to say, I basically want to go over to the 3D color over here and say, look, any of them that are 3D body and happen to have the same color, which would be the one in the center, I also want those to be the same as well. Okay. So there's a couple of features down here below, and some of them should be turned on if you don't have them turned on. First, I'm going to be making a change to the whole library. So again, this is why you don't want to be doing this in a nice formal library. It's something that's good to be doing in a side library, so that you don't impact those things that may also fall under this. Because remember, any 3D body with this color here is going to be picked up. We're also going to clear the existing, make sure that nothing was selected either in this component or a prior component. And we're also going to run the inspector because the inspector allows us to do a global edit. All right. So I'm going to press OK. Okay, and you're going to notice that there's 38 objects selected because effectively we've had 38 different components over here. And what I can do over here, for example, is like 3D color. So I can click on this and I can change all the properties at once. In fact, what you're seeing over here is that these were all the properties of all of the 3D bodies. If there's something that's different on those properties, they'll put the little caret heads over here with the 3 dots saying, look, each one of these has a property that might be different from each other. But these are all the same, so I'm going to click on this little button here and I'm going to change its color to black, for example. Let's go up here and I'm going to click on number 3. I'll press OK. And the minute I press enter, it's going to forewarn me that all of these are going to get changed, and I'm going to say yes. All right, and now all those properties are going to change. Now, if there's hundreds of them over here, this could take a moment or two because keep in mind it's going through the entire file and having to make that change to every single primitive. If I hit the 3 key, I now have black, and not just on this one, but any of them that had gotten selected. Okay, and I'll just rifle through them, and now they've all been changed. So appreciate your time on this video here, and good luck with it. And we hope that we can put out a few other videos in the very near future. If you have any questions about this, feel free to put those in the comments, and certainly do put some comments in the forums for Altium, because I think it'd be good for them to know that this particular function is seeing the light of day again, and I know that they'll improve it if there's a lot of interest in it. So again, thank you for your time, and good luck in your engineering endeavors.